right? If you have a system, let me just give you a very simple example, something that is related but not obviously. So if I have an error, let's say at step k plus 1, is equal to a matrix times the error at step k. So the error here is a vector, right? How do I figure out if the error is going to grow or not? Well, if the matrix A is let's say half and a third, is the error going to grow or decay? It's going to decay, right? Every step you get multiplied by something smaller than 1. Okay, if I get A that is equal to 2 and minus 1, is the error going to grow or decay? Huh? It's going to grow, right? So the first term of the error gets multiplied by 2, right? It's going to grow. How about negative 2? Is it going to grow or decay? Huh? Grow, right? Every step you get multiplied by negative 2. So the magnitude is what it matters, right? It gets bigger and bigger. Now here's the tricky question. How about let's see, 1 minus 1 minus 1 1. How about that? Is the error going to decay or grow?
Other matrices are the corners.
Oh, the other matrix is when I don't see anything is 0. Sorry, I mean that's kind of the when I write a matrix, when I just leave something empty, it usually means it's 0, right? So how about this one, right? If you have this matrix and I keep multiplying it by a vector, is the vector going to grow or it's going to decay? It stays constant? Are you sure? Can you try it? It depends on what your EK is, right? But like, let me just try it, right? I have MATLAB, you don't. So if you can bring computer next time, it'll be very helpful. So A equal to 1, what is it? 1, negative 1, negative 1, 1, right? So just to give me a random vector, E0. Huh? 1, 2. 1, 2. Okay. Okay, 1, 2. Okay. So let's say E1 equal to A times E0. Okay, I get a E1. So when I multiply a matrix multiple times, what does it mean actually? I can just take a power of the matrix, right? Okay. So let's say E100. Okay. Is equal to the matrix to the 100th times E0, right? I can do it 100 times. You get the same answer. Okay, give me another random vector. 0.1. Well, it's proportional to the previous vector. I get the same number. Get me a different one.
7.
Negative pi, okay. I like that. 10 to the 30, right? Give me another random vector. 1, 1. Well, you are you are nasty, right? Give me something that is different from 1, 1. Well, that's the same, right? From linear algebra perspective, it's the same. I mean, the reason it's called a linear algebra, I mean, what do you mean by linear, right? If you multiply the operand, I mean, if you multiply the input by 2, the output is multiplied by 2, right? So 1, 1 and 2, 2 are the same thing, so it doesn't count. 29.7. Well, 10 to the 31. All right, so anything that is not 1, 1 is going to get something crazy. I mean, 1, 1, I think you actually look at the matrix. If you do 1, 1, you get zeros, right? So yeah, actually it brings a question like why do you get huge numbers always except for when you have 1 1?